Alrighty, here we go. This is Unit 6, Lesson 3. We are going to be solving systems by elimination. So far we have solved systems by graphing and by substituting, and now we're going to learn what elimination looks like. Remember I talked about in the last video that it's a good idea to kind of look at your systems and see which would be the best way to solve, and so just continue thinking about that as we do these examples. So here are the steps. You're going to write the system so that the like terms are aligned, okay? So like if we think of standard form, right, this is standard form, okay? When I write the two equations, they need to be lined up. So what does that mean? That means if I have an equation like this, then my other equation should also be written like that, okay? Or if I want to do it, or maybe I have, like for instance, 3y minus 2x equals 6. Then my other equation should look something like where you have the y, then the x, and then the constant. Okay, so they need to be lined up. That's what that means. We're going to use addition or subtraction to eliminate a variable. Okay, so let's go ahead and get into this, and you can go back and read the steps later. So for example, x minus 2y equals negative 19, and 5x plus 2y equals 1. So you can see that the variables are already lined up, the x's, the y's, and the constant. Okay, this is called the constant. So now we need to look at the coefficients of the variables. So what's the coefficient of this x? It's a 1. Okay, what's the coefficient of this x? It's a 5. So if I add or subtract that, am I going to get 0? No, 1 plus 5 is 6 and 1 minus 5 is negative 4. That's not going to work. Let's move to the next one, negative 2 and a 2. If I add or subtract those, will I get 0? Yes. Now what do I need to do? Do I need to add or do I need to subtract? I need to add. Negative 2 plus positive 2 is 0. So that's what I'm going to do is I'm going to add these equations to each other. So I'm going to add each column. So what is x plus 5x? 6x. Negative 2 plus 2 is 0. So I'm not going to put anything there because I don't need to. And negative 19 plus 1 is negative 18. Now I need to solve for x. Notice that there's no y anymore. So I'm going to divide by 6 on both sides. So x equals negative 3. Now this is very similar to substitution in where now we have part of our answer. So we know the first part of our answer is going to be negative 3, but we're missing the y. So what do I need to do? I need to plug this back in for one of these x's. Okay, it doesn't matter which equation I choose. You can pick the first one or the second one. All right, so I'm just going to pick the first one. So negative 3 minus 2y equals negative 19. Okay, so I'm solving for y. So I'm going to add 3 to both sides. So negative 2y equals negative 16. And now I'm going to divide by negative 2. So y equals 8. So the second part of my answer is 8. So this is my solution, negative 3, 8. So why was this easy to do with elimination? Some of y'all may be thinking, that was so easy. Why can't we do it like that all the time? The reason it was so easy is because the coefficients were the same but with a different sign. Okay, or even if they're the same with the same sign, you can subtract, but they had the same coefficient. And that was really helpful. Okay, so that's what we're looking for when we're looking to eliminate. Let's look at the next one. 3x plus 4y equals 18, and then negative 2x plus 4y equals 8. So in this scenario, the 3 and the negative 2, that's not going to work. But the 4 might work. But how do I get 0? Well, they're both positive, so I need to subtract. So this is very tricky. You have to make sure that you actually are subtracting this from this. Okay? Another way you can think about it is you can multiply a negative 1 times that bottom equation on both sides. What does that give me? That gives me a 2x minus 4y equals negative 8. And then, so if you distribute the negative to the bottom equation, then you could add the top equation. So because I distributed, now I can add this. Okay, I'll come back to that in a second. Let's go back and do the subtraction. So you just have to think carefully. What is 3 minus negative 2? It's 5x. What is 4 minus 4? 0 is our whole point. 18 minus 8 is 10. So the real tricky part is when you have the subtraction and you have a negative. Don't forget that that turns it to a plus. Divide by 5, x equals 2. So what does it look like here? It's going to be the same thing. 5x equals 10. Okay, so x equals 2. So you can choose to do it either way. If they are the same sign, if the coefficients are the same sign, you can multiply the bottom by negative, the entire thing, don't forget the 8, and then add, or you can just know that you're subtracting, okay? So now we have part of our answer, so I'm going to plug it back into the first equation. All right, so I'm going to plug in a 2 for x, so 3 times 2 plus 4y equals 18. So 6 plus 4y equals 18, minus 6, so 4y equals 12, divide by 4, y equals 3. So my solution is 2, 3. So again, the coefficients were the same. They were the same sign, so we subtracted. Whereas up here, the coefficients were the same, but they were different signs, so we added. We still eliminated a variable. All right, let's go to the next page. All right, 2x plus y equals 3 and negative x plus 3y equals negative 12. So here I have a 2 and a negative 1. Those are not the same. And I have a 1 and a 3. Also not the same. Okay, well, how am I going to eliminate? Well, what you could do is you could multiply one of these equations by a factor so that the coefficients would then be the same. So in this case, you always want to look at if there is a variable with a coefficient of a 1, that's going to be really easy. So this has a 1. If I multiply by 3, then it's going to be a 3, which is going to match. Okay? Now, if you want to add, you need to multiply by a negative 3. Okay, so that's what I'm going to do. I'm going to multiply the top equation by negative 3. Okay, so I multiplied by negative 3 on both sides. So I'm going to get negative 6y minus 3y equals negative 9. And now I can add that to my bottom equation because now the y's have the same but opposite coefficient. So now I'm adding. So negative 6 plus negative 1 is negative 7x. Negative 3 plus 3 is 0. Negative 9 plus negative 12 is negative 21. Divide by negative 7, x equals 3. Okay, so we couldn't eliminate originally, but once we multiplied the top by negative 3, we were able to eliminate, and that's totally fair as long as you do it on both sides. Okay, by the way, we could have also multiplied the bottom by 2. If we would have multiplied the bottom by 2, then this would have been a 2 and this would have been a negative 2, and they would have canceled. Okay, so you had options there. All right, we're not done. So x equals 3. So let me go back and plug that in. So 2 times 3 plus y equals 3. So 6 plus y equals 3 minus 6, y equals negative 3. So my answer is 3, negative 3. All right, last one. 5x minus 2y equals 4, 10x minus 4y equals 8. Okay, I don't see anything lining up. So can I multiply by something? Well, sure, it looks like if I multiply the top by 2, then this will be the same. Okay, so that's what I'm going to do. And actually, I'm going to multiply by, I'm just going to multiply by 2. So 2 times 5x minus 2y equals 2 times 4. So 10x minus 4y equals 8. Now, hopefully you're noticing something here, that when I multiplied this by 2, it became this. Okay, so now I have the exact same thing. Well, if I want to eliminate, let's say, the x, how would I do that? How do I make 10 and 10 be 0? I don't add, I subtract. So 10 minus 10 is 0. Negative 4 minus negative 4. Negative 4 minus negative 4. That turns into plus plus, so that's 0 also. And 8 minus 8 is 0. So what do I have? I have 0 equals 0. So my variables are both gone, but is my statement true? Does 0 equal 0? Yes, it does. So what does that mean our answer is? That means our answer is infinitely many solutions. Okay? When our variable disappears and we come out with a true statement, it's infinitely many. Remember, if our variable disappears, if they both cancel and I get 0 equals 8, okay, 0 does not equal 8. So if that's what I went up with, that would be no solution. Those would be parallel. Remember, these are the exact same line. That's why it's infinitely many. They literally overlap each other. Okay, so if it's a true statement, it's infinitely many. If it's not a true statement, then it's no solution. All right, so that's how you solve systems by elimination. Again, you want to start to recognize when to use what method so you can do it in the most efficient way possible. Great job. Review anything you didn't understand, and I'll see you in class.